All right, let's jump right in. Welcome to today's explainer. If you love understanding exactly how the physical world works around you, well, you are definitely in the right place. Today, we're exploring the science of floating. We're going to use an awesome visual experiment from Dave Hacks to break down why everyday objects sometimes behave in ways that totally defy our expectations. It's all about structure, layers, and the hidden rules of physics. So, let's get started. I want you to take a second and really picture this. Can a grape float right in the smack dab middle of a glass? Usually, when we drop something into a liquid, we expect a pretty binary outcome. It either crashes down to the bottom like a rock or it bobs along the surface like a beach ball. But what about the space in between? How can an ordinary everyday object perfectly suspend itself in mid-liquid?
Section 1. The magic of floating. Define gravity in a glass.
We are about to completely flip the script on that old assumption that things just have to sink straight to the floor or float right at the ceiling of a container. The original creator of this experiment, Dave Hacks, really sums it up perfectly when he says, "Pretty cool, huh?" That really captures the sheer amazement of watching everyday objects perform this incredible balancing act. But as focused learners, we know there's an entire world of physics happening right in the middle of that glass, just waiting for us to unpack it.
Section 2. Building the liquid layers, setting the foundation. Okay, before we can start tossing things in and watching them float in the middle, we've got to engineer our environment. And we're doing this using 3 specific liquids you probably already have sitting in your kitchen pantry right now. Now, this step-by-step process is absolutely crucial. Step 1, you pour in the syrup. As the source notes, this has to go first because it naturally sinks right to the bottom. Step 2, carefully add water on top of that. And finally, step 3, pour in the cooking oil and just leave the whole shebang to settle. If you follow this exact order, you aren't just making a sticky mess, you're actively building a beautifully stratified 3-tiered liquid tower.
Section 3. The drop test. Where will they land?
All right, our 3-part liquid foundation is perfectly built and settled, so the real experiment begins. Let's look at the stark contrast in how different items behave here. First up, we drop a heavy metal nut. It sinks right down to the very bottom, totally submerged in the syrup. No surprise there. But what about the grape? When we drop it in, it sinks right through the top 2 layers, the oil and the water, but then it stops, sitting directly on top of the syrup. It's literally hovering right there in the lower middle of our tower. It's such a fantastic visual representation of the concept we're talking about.
Now for our final 2 objects. We toss a bottle top in, and it slowly sinks through the oil layer, but then it stops completely, sitting squarely on the water. So it makes it exactly 1 layer down. But then we have the piece of sponge. It simply refuses to sink at all. It just stays right there, floating on the very top of the oil. So we've got 4 different items, and 4 completely different resting places. Why does that happen?
Section 4. The secret is density. Unlocking the science.
Well, it's time to pivot from the what we're seeing to the why it's actually happening. And the secret ingredient? It all comes down to density. That's a scientific property that causes the syrup to sink below the water in the first place, and it dictates exactly where each dropped object is going to park itself. Like the source material points out, the grape sits on the syrup purely because it is, quote, not quite as dense as that heavy metal nut. Basically, the final resting place of every single item is entirely based on whether it's more or less dense than the specific liquid layer it's passing through.
If we look at the relative densities of our 3 liquids, syrup has the absolute highest density. That is exactly why it anchors the bottom of our glass. Water sits right in the middle with the medium density, and cooking oil has the lowest density of the 3, which lets it rest gently on the very top. So the liquids themselves actually sorted themselves out by density before we even dropped anything in.
So the crucial point here is how our 4 distinct objects interact with that liquid structure. Let's summarize how they physically stack up. The metal nut is the densest object of all, so it just pushes through everything. The grape, it's denser than the oil and the water, which is why it falls through them, but it's less dense than the syrup, so it gets caught right on top of it. The bottle top is denser than the oil, but less dense than the water. And the sponge is just the least dense object overall, keeping it right at the surface. It's like a giant puzzle that perfectly solves itself.
Section 5. Recreating the magic. Science in your kitchen.
You know what I truly love about this explainer? It's just how incredibly accessible it is. You don't need some high-tech laboratory to observe the strict, fascinating rules of physics in action. The magic of physics is literally hiding right in your syrup, water, and oil.
When you understand a core property like density, it instantly transforms incredibly ordinary, everyday kitchen supplies into this mesmerizing, highly structured science lab. It really empowers you to see the invisible forces that are constantly organizing the material world all around us.
So, I want to leave you with this final provocative thought. What other everyday items have a secret density just waiting to be tested? Seriously, now that you understand the mechanics behind this density tower, I highly encourage you to go look around your own house. What happens if you drop a blueberry in there? What about a plastic building block or maybe a paperclip? Go build your liquid layers, drop some items in, and track their journey. Thank you so much for joining me for this explainer. Keep asking questions, and I'll see you next time.